Welcome to Flight Ops. In just a few steps, you'll be ready for your first flight. Before we begin, let's get familiar with the interface. To access the C2 application, open the URL provided, enter your username and password, agree to the terms of use, and log in. This brings you to the main control panel, where all flight operations are managed. At the heart of the interface is a map area, displaying your drones in real time. On the left panel, you'll find the Missions panel, currently empty since no missions have been created yet. Next to it, the Resource panel houses the drone list. In this example, 3 drones are present: Drone 1, Drone 2, and Drone 3. Each drone provides telemetry data, including connection status, indicated by 3 green dots when the drone is fully operational; battery level and GPS signal strength, measured on a 1 to 5 scale, with 5 being optimal for flight; altitude above takeoff point ATP, which remains 0 while on the ground; mean sea level MSL, representing altitude relative to sea level; velocity, which is 0 when stationary. Clicking a drone centers it on the map, allowing you to zoom in and observe its exact position. Drone panel functions. Below the drone list, 3 key controls are available. 1. Enable powers up the drone for flight. 2. Delete NFC, removes designated no-fly zones. 3. Show ground level graph, displays terrain elevation data. Mission configuration. Before launching a flight, system parameters need to be set. With no active missions or drones, the configuration panel becomes accessible, allowing adjustments to mission settings. Key configuration parameters. Minimum altitude, the lowest flight level for drones in your system. Maximum altitude, the highest altitude the drones can reach, ensuring compliance with airspace regulations and obstacle clearance. Example: 40 meters for safe operation over trees or buildings. Altitude separation gap, ensures safe spacing between multiple drones in the same airspace. Recommended setting: 10 meters. Return home RH, energy on ground, the battery percentage required for a safe return and landing. No COM RH trigger, defines how long a drone can remain disconnected before automatically initiating return home. Saving these settings updates the system in real time. Defining the flight perimeter. To establish a safe operational area, the perimeter button opens the perimeter menu, where perimeters can be imported or exported from saved configurations. Manually drawn by outlining a polygon over the desired flight zone. Once set, the perimeter appears as a blue boundary, marking the designated airspace. Anything outside this area is classified as a no-fly zone NFC. The perimeter can be edited and updated at any time. Adding no-fly zones NFZs. A no-fly zone is an area where flight is restricted or prohibited. To create an NFC, 1. Define a polygon over the restricted zone. 2. Optionally, assign a name and altitude limit. If no altitude is set, the NFC is absolute, meaning no drone can enter it at any height. If an altitude is specified, drones may fly above it if permitted. 3. Confirm to finalize the NFC. Launching a mission. One of the fastest ways to get a drone in the air is by creating a target tracking mission. First, select a target location on the ground, then set the desired distance between the drone and the target and the observation angle for the drone's perspective, the direction from which the drone will approach, in this example from the east. Confirming, and the mission is automatically created and armed, appearing in red. The user assigns a drone by clicking Enable, in this case Drone 3. Enabling the drone initiates a route calculation process and the allocation of the drone to the mission, initiating an automatic takeoff sequence. As the drone climbs, the altitude display updates continuously. And upon reaching operational altitude, for example 60 meters, the drone proceeds directly to fly the mission route towards a target point, creating a dynamic green no-fly zone around it. Adjusting observation points. While in flight, the camera locks onto the target automatically, and the observation point can be manually repositioned by dragging and dropping it. Similarly, the drone's location can be adjusted in the same way. Returning home and landing. Once the mission is complete, the drone must return. You can do that by stopping the mission. This action instructs the drone to look for any available active missions. And if none exist, initiate return home. Alternatively, return home can be triggered manually. During the landing sequence, the drone aligns with the designated landing corridor. The system messages panel logs all commands, alerts, and mission status updates, allowing you to view alerts and errors in real time. As the drone descends, it gradually reduces altitude before transitioning to not active upon landing. Mission complete. Congratulations! You have successfully completed your first flight ops mission.